Hello, welcome to a word problems video on proportions. You'll be able to use what you know about proportions to solve word problems. So the main question is, how do I write proportions from word problems? There are 3 steps that you will want to follow. The first step is you want to read the problem and box in the question so you know what you're trying to find. The second step is to read the problem and underline important information, basically your numbers and your labels. Notice that you are reading the problem twice, and that's important because it helps you remember key information. And step 3 is to write in a proportion with labels, and including the labels is the most important thing because otherwise you're going to set it up wrong if you don't, or at least you potentially will. And I don't want you making those silly mistakes, so be sure to label it. Alright, I will give you some examples walking through these steps. In this first example I have, in the typing world, 80 words per minute is considered acceptable. How many words per minute is this? How many words per 30 minutes is this? So I just read the problem, now I'm going to box the question. That's how many words per 30 minutes is this. Then I'm going to read the question again. In the typing world, 80 words per minute is considered acceptable. How many words per 30 minutes is this? And now I'm going to underline keywords and their labels. So 80 words per minute, and then 30 minutes as our keywords. And I know that words per minute, per means that it's a unit rate, and unit rate is always 1. So per 1 minute is what we're talking about. So now I can set this up using a proportion. I have my 2 labels being we're talking about rates here. I know that I have words and minutes as my label. And I want to set this up proportionally. So my words are 80 words in 1 minute. That's my first proportion, and that's going to be equal to, and then 30 minutes, and this is where your labeling comes in handy because now you know where to put the 30 in the minutes section. Then I have my unknown variable because I don't know how many words that is, which is what we're trying to find to answer the question. So now that I have my proportion set up, I can solve for x. In this case, it's pretty easy. 1 times what is 30? Well, that's easy. It's 30. So 8 times 30 will give me my answer. And 80 times 30, is 2,400, which means to answer the question, it would be 2,400 words in 30 minutes. So that's the first example. We'll do a couple more together. Here we go. Next problem. In a shipment of 400 parts, 14 are found to be defective. How many defective parts should be expected in a shipment of 1,000? So we're first going to unbox the question. So how many defective parts should be expected in a shipment of 1,000? I'm going to read it again and then underline the important words. In a shipment of 400 parts, 14 defective, and then how many defective parts should be expected in a shipment of 1,000. So those are my important words. Now I can write proportions. I have parts and total parts, and then defective parts are my labels. 14 of them are defective, and that's my label. And then out of 400 total parts equals, and now this is why I label, so now I know where my other part information goes. A shipment of 1,000, is that 1,000 total, is that defective or is that total? So you have to figure out. And because we know that we're solving for defective parts, we know that the shipment of 1,000 is referring to a total number of parts. So that goes in the parts label, and then I solve for my unknown variable. Now we just are solving a proportion. You can scale across. If that doesn't work very easily, you have simplifying fractions, and if that doesn't work, then you can go to your unit rate. I know at this point you're comfortable with scale factor, so I'm not going to show you that way. Plus, it's not an easy number. So I'm going to simplify this, and I will get 7 over 200 equals x over 1,000. Now we have easy math because I know that 200 times 5 will give me 1,000. So I go the same way and do the same operation. And 7 times 5 is 35. So I know that there are 35 defective parts in a shipment of 1,000. Alright, last example here. A frame is 9 inches wide and 8 inches tall. If it is reduced to a width of 3 inches, then how tall will it be? Read the question, box the question, and really it's not the whole sentence here, it's how tall will it be? That's the question. And then underlining important words. 9 inches wide, 6 inches tall. Width of 3, which is talking about how wide it is. So now that I have that, I can talk about my proportion. I know that I'm talking about length and width, or sorry, I should say height and width. So height and width are my two labels. And it doesn't really matter right now which way you can flip it. It's not a huge deal as long as you are labeling. So the height was 9, and when it was 9 inches wide, the width was 6, which equals, because we're proportional, so it's balanced, it's being reduced and increased equally. I have a width of 3, so I put that in the width column and solving for x. I can multiply across, up and down, whatever. Sometimes scale factor works, sometimes unit rate. This way I divide by 2 on both sides, or on the top and the bottom I should say, and then I will get an answer of 4.5. And so to answer the question, we are talking about 4.5 inches tall. Alright, it is your turn to solve this question using underlining, using boxing the question, showing all of your work, especially your labels, and then I will share the answer with you in class. Thank you for watching. Have a great day.